Hi everyone, welcome to my YouTube channel. I am RVS Harshni studying in Sri Venkateshwara College of Engineering. Today we are going to discuss on engineering electromagnetics. The topic today we are going to discuss on engineering electromagnetics is Gauss law and its applications. Introduction to Gauss law. Gauss law relates the electric flux through a closed surface to the charge enclosed within that surface. It is a fundamental principle in electrostatics formulated by the mathematician Carl Friedrich Gauss. The law can be mathematically expressed as psi of E equal to Q enclosed by epsilon naught, where psi E is the electric flux, Q enclosed is the enclosed charge, and epsilon naught is the permittivity of free space. Electric flux and Gauss law. Electric flux definition: delta of psi E is equal to EI delta AI cos theta. That is equal to EI dot delta AI. Psi A is equal to surface integral of E bar dot dA bar. Gauss law is nothing but integral of E dot dA equal to Q in by epsilon naught, where Q in is the net charge inside the surface. Mathematical formulation. Gauss law can be derived from Coulomb's law and is often used in conjunction with symmetry arguments. The law states that electric flux through a closed surface is proportional to that enclosed electric charge. The differential form of Gauss law relates the electric field diverging from the charge density by the equation del dot E equal to rho by epsilon naught. Applications in spherical symmetry. Gauss law is particularly useful for calculating electric fields of symmetrical charge distributions such as spheres. For a uniformly charged sphere, the electric field outside the sphere behaves as if all charge were concentrated at the center. This simplification allows for easy calculations of electric fields in various scenarios involving spherical charge distributions. Applications in cylindrical symmetry. In cases with cylindrical symmetry, such as long charged cylinders, Gauss law simplifies the calculation of electric fields. The electric field outside a charged cylinder decreases with distance from the axis, behaving like a line charge. This application is frequently used in designing cylindrical capacitors and analyzing charged wires. Applications in planar symmetry. Gauss law can also be applied to infinite plane sheets of charge to find the electric field produced. The electric field generated by an infinite sheet is uniform and directed away from the sheet, independent of distance. This principle is crucial for understanding fields around charged plates in capacitors. Gauss law in magnetism. Gauss law has an analogous form in magnetism, stating that the magnetic flux through a closed surface is zero. This implies that there are no magnetic monopoles. Magnetic field lines always form closed loops. This principle helps in understanding the behavior of magnetic fields in various physical systems. Applications in electrostatics. Gauss law is instrumental in electrostatics, particularly in calculating electric fields and potentials. It helps explain the behavior of charges at rest and provides insights into electric field lines. Understanding these concepts is vital for the design of electrical components and systems. Applications in engineering. Engineers use Gauss law in designing circuits, capacitors, and other electrical components. The law aids in determining how charges will distribute and interact within various materials. This application is critical in optimizing the performance of electronic devices and ensuring safety standards. Limitations of Gauss law. While Gauss law is powerful, it is most effective in situations with high symmetry. In cases with irregular charge distributions, calculating may become complex and less practical. Understanding its limitations is important when selecting the appropriate method for solving electrostatic problems. Summary and conclusion. Gauss law is a cornerstone of electrostatics, providing a means to analyze electric fields and charges. Its application range from theoretical physics to practical engineering problems, showcasing its versatility. Mastery of Gauss law is essential for anyone studying electromagnetism or working in related fields. Introduction to Electrodynamics, Electricity and Magnetism, Physics for Scientists and Engineers are the following books by which we can learn more about this topic. Thank you everyone. Please like, share and subscribe.